Hello, this is Gary Marr of Glendale Community College. This screen captures for my SAS 166 AA JavaScript students, and what I'm going to do today is cover a series of PowerPoint slides from chapters 3, 4, and 5, which roughly kind of act as a review from week 2 and also the start of week 3. We will not have class in week 3 because it's Labor Day, so this is kind of a substitute. We're going to review some material, and we're also going to see some new material. I'll follow these slides up with another presentation that goes through some sample code that will show you specific examples of what I'm going to talk about in these slides. A lot of these slides I'm going to just kind of brush through, talk about them briefly, and then we'll back up the discussion with an example in code. Starting with relational operators. Relational operators are probably familiar to some of you, maybe most of you. They're like arithmetic operators. Okay, they're a symbol, but different than arithmetic operators. These operators, when you have an operator on either side of them, will evaluate to be either true or false. Okay, they will form something called a conditional statement, which is also called a conditional expression, which is also called a Boolean expression, because when I put operators on either side of these, it's evaluated, it'll be true or false. Take note that the equals operator is double equals. That would be different than the equals arithmetic operator, which is what's called an assignment operator. Assignment operators take everything in the right side and stick it to what's defined on the left side. That's not what this does. This simply makes a comparison to determine if it's equal. If it is, it's true. If it's not, it's false. Some examples. If last name is Hooper, that would be true. If test score is 10, that would be true. Here's some other examples. These are conditional expressions, also called Boolean expressions, because a Boolean variable has only two values, or can only have two values, true or false. This is another built-in Boolean expression to JavaScript. It is not a number. There's a bunch of these in JavaScript. You'll see some of these in the readings for Chapter 3. Along with conditional expressions, we have, in relational operators, we have logical operators, which essentially allow us to take multiple relational operations, like age greater than 17 and score less than 70, and use this as one very large expression that evaluate together as either true or false. So if age is 17, let's say the age, or greater than 17, let's say age had a value of 20, and if score is less than 70, let's say score was 30, this would be true because both of these expressions are true. When joined by the AND symbol, for it to be true, both expressions have to be true. If one of them or both of them are false, the expression will evaluate as false. You'll see why that's important in just a second, because the next set of slides you're going to talk about if statements. With an OR, any one side has to be true, and that's all. Oops, wrong way. Here's an example here. We can look at the syntax up top. Here's an example down below that's probably easier to understand. If age is greater than 18, so if the age up here somewhere in our program was stored at 20, if it's 20, then 20 is greater than or equal to 18. The alert box, which is that built-in JavaScript function which has a dialog box, would say you may vote. If it's false, in other words, the person is 12, then it would say you're not old enough to vote. With if statements, this is called a decision structure. And structures really would start to make our JavaScript program have, I guess, more intelligence, allow us to branch off to different parts of logic or take different pathways based on how the program's developing, based on input from the users. So in this case, if this was an application with a web page that determined whether or not you're old enough to vote, we would have this JavaScript in there, and based on what they keyed in as their age, we would tell them yes, they could vote, or no, they couldn't vote. Here's a more elaborate example of both the is not a number and also else if to evaluate a variable called rate. Typically, else ifs are used to evaluate the same variable for multiple values. And keeping in mind here that if this is true, it drops down to here, okay, and it continues to follow this. If any one of these are false, you're going to have a pop-up box again saying it is false. And if everything comes through here, or if it comes through and actually evaluates all of these as false, in other words, it's good data because all the tests came back in a positive way, they didn't, hit the threshold, then you're going to get a message in alert box that the rate is, and it's going to give us that rate. The plus symbol in this case is concatenation of strings. So this string joins this, even though rate may be a number, okay, it should be, I guess, based on what this logic is saying, then it will concatenate because the first value is a string. If you try to concatenate a numeric variable with a string, it might give you a problem because it's going to try to do math with it. But the concatenation symbol with strings is simply going to join the strings, put them together into one longer string. And you'll see that in some of the code we're going to talk about today. Another compound expression with an OR. This is a test for Boolean values. So is valid or is not a number is going to be true or false. Notice the type case is, because JavaScript is type case sensitive, is lowercase t and lowercase f on the false. A while loop is another programming structure which really kind of reduces the number of lines of code, so therefore it simplifies the code, makes it easier to read, less likely for errors. What it does is loop through a series of code. What this particular operation is doing here is it's setting one value to be evaluated. It's setting another value which represents the top end, and it says as long as counter is less than the number of loops, if that's true, because this works all like an if statement, then it'll execute the body of the loop. If it's false, it'll jump down here with the alert statement and display the sum of numbers. So if I was to follow this through, it's 0 and 5. It says the counter is 1. So if 1 is less than the number of loops being 5, less than or equal to, it is, it will go inside the body of the loop. What it would do there, it'd say, okay, for the variable called sum of numbers, which currently is 0, let's add the counter to it. The counter is 1, so sum of numbers becomes 1. Then it adds 1 to that counter variable, so now it's 2. It says, is 2 less than or equal to the number of loops? Well, 2 is less than or equal to 5, so we'll go through the steps again. Now it's 3, 4, 5, and this is less than or equal to. If it tried to go to 6, that would make it false. It would come down, print, or execute this alert statement, which would display the sum of the numbers we just brought in to the screen in a dialog box. Do while loop is still a loop. It's slightly different in that rather than testing at the top of the loop for the Boolean expression, it tests at the bottom. So what happens here is the body of the loop will always be executed at least once, then the test will occur. As opposed to the while loop where if counter was set to, let's say, 7 right here in this statement, it would never enter the loop. So it's possible for a while loop never to be executed, the body of it anyways, but yet the body of the do loop always is executed at least once. Which one of these you use is really more or less personal preference, because how the loop is initialized and set up, the Boolean expression, will determine if it's going to work or not. Chapter 5, we'll start looking at debuggers, which helps us find errors. That's an important part of, doing this kind of code because it's more sophisticated. We don't think like machines. So when it comes like if statements and do loops and while loops, sometimes we have to kind of step through the code line by line and look at what's happening as variables are changing, and also the pattern of the code, which branch it takes. That's what the debugger will help us with, and we hope we'll get a chance to talk about that today also. Moving on, there's an example of the do while loop. And if any of these particular examples are problematic and you're having a hard time understanding them, just send me an email and I'll be more than happy to go through it with you. Or we can talk about it again in class. A for loop is another kind of loop. These are popular with what's called arrays. We actually, I believe, have arrays in either this chapter or the next one. We're not going to talk about arrays right now. We're going to do that a little bit later. But what arrays are is a series of values that have a subscript starting with 0. And that subscript acts like an address to get access to that array element that holds some value. So it's very common for when you're working with arrays to use a for loop, because how a for loop is different than a while loop or a do while loop is that it's going to be what's called it has a definite incrementer. So it's not indefinite but definite. And so what it's going to do is it's going to start with a number, in this case is 0, and then it's going to count through it by ones, usually whole numbers, integers, 1, 2, 3, 4, 5. Whereas a while loop or a do while loop can actually test whether it's going to continue based on something besides a number. Maybe it's a color, maybe it's an age, maybe it's a name, a city, a state, a zip. You'll see that in some of the examples today also. Most of these programming structures we just talked about here will demonstrate in code in the textbook, and then it's up to you. Probably just do a lot of programming with it to test it, make sure you understand how it works. It really is, all of programming really is to get good at it, is really just a matter of practice. Don't be afraid to make mistakes. The mistakes are what you remember, and as long as you don't make the same mistakes repeatedly, you're eventually going to build up a whole lot of knowledge and get very good at it. We're going to save this one for later, or something like it for later, when I go through some of the sample code in brackets. That is the end of that presentation. The next one is on chapter 4. We didn't really get a chance to talk a lot about this particular chapter in class, so I may go a little slower here. For starters, there's all kinds of built-in functions in JavaScript. And these built-in functions are functions that were created for you because they're so generic and they're so widely used, they included them with a language. Two of them are what's used to change the data type of either a stored value or a string or numeric literal. So in the first case, this would be a string literal. If I had a value in here that was a string of the value 2, what parseInt would do is it would convert that string value of 2 to the number 2. On the float, if I had a value of 2.2, it would convert 2.2 to a number 2.2. This way I could use that for calculations. You'll find that when you use the prompt built-in function for JavaScript, it's going to store whatever you key in the keyboard as a string. It will, and if that value it's storing is going to be a number used in a calculation, you will have to convert that to either integer or floating point for your calculations. And you'll see some examples of that today. Here's an example right here. Enter a value. Okay, the default value would be this. You don't have to have a default value. They've got one. But it's basically asking to key something in the keyboard. If I hit the number 6, it's really a letter at this point because that's how the prompt function works. Okay, what I would have to do is convert that to a number. So here I say, okay, that value I just captured, let's use that. Let's parse that into an integer and store it back into the same variable name. So if it started off as 1, 2, 3, 4, 5 dot this, once the parseInt hit it, it would come back as 1, 2, 3, 4, 5. If I did parse float for the same number, that would come back with its decimal, because that's the difference between parseInt and parse float. One accommodates a decimal, one does not. These are important. We'll see these in the code. I would say write and write line are something we'll learn to use very early, and then we probably won't use it as much. More about that later. Get element ID we use all of the time, because what this does is that ID value is the ID attribute on your HTML statement. So this is one way of pulling information off the screen and also placing some sort of new information you've calculated in JavaScript back on the screen inside a text box. So this works with the input tag in HTML. Here's an example. In our HTML, you have something with an ID of rate. And what it does here, it says, okay, let's take and pull that value and store it something called rate box. Rate box now holds that object. Along with it is the value of the object and some other information you could use to manipulate the page or manipulate the DOM. Here's an example of write, and we'll have some of these. All write does is simply send this to the browser and say print this. The problem with using write and write line is it could be a little awkward in terms of getting the data formatted correctly on the screen. So typically I think probably a better solution would be to make sure that you have a spot for all of the input data and a spot for all the output data with input tags in your HTML, and then using the get element by ID to grab information and then place it back. You'll see some examples of that today also. Some other properties. When we're working with text boxes, and you'll see this in JavaScript, there's a focus method which puts the cursor on that field. The value we'll use a lot for grabbing information out of a text box. Disabled would make it unavailable, and 2 digits would be a way of taking and modifying the decimal value of that value that we grabbed. We'll see some examples of these, and that's not one of them there yet. It's part of one. Here the ID is first name, the ID is sales amount. Here we take first name, and typically the way we'll do it is we'll chain the operation. In other words, we'll pull the data, and then we'll at the same time pull its value. Now this is in 2 steps. This is in 1 step, and this is typically how most of the examples will come out. It's called chaining, and basically what happens, it does this first. Well, with chaining, it does this first, pulls the information, and then from the object, which contains a lot of information, but most importantly, it contains a value, it'll pull the value and then store it in a variable called first name. And you'll see that today too. More examples of chaining. The date object is another built-in object. You can use the window, the document, and the date object for starters. There's other objects that are built in too. And an object's like a super variable. It has data in it, but it also has helper methods, which is what these are up here, to pull information out of that data object. So you'll see today that when I actually create a new date object, it's going to pull the date from the system, from the PC, and then I'm going to break it apart in pieces by using these methods. Okay, I have an example of that you'll see later. And again, I'm going to talk about it here. You can read it in the book also. Strings are simply just sequences of text. Here's some very popular methods used for them. There's a lot more examples in the book that we're going to hit upon today. This is important. Look at it. You will see it. I'm not sure today in the examples, but very shortly. Okay. This is a function expression. This is one of the major deliverables from this chapter. And what this says is we've got some code that we want to run. Whoops, I'm sorry. We got these 2 lines of code we want to run together always. So what we're going to do is we're going to create an anonymous function, which means that we got a function but with no name. This is contrasted with named functions, which is the other topic we're going to cover in this chapter. An anonymous function typically has a variable that holds the information. It can have parameters here. This one does not. And when it's called, like it is down here, show year, it looks for the variable called show year. It looks to see if it's an anonymous function. Run these 2 statements, one of which is to show information on the screen. Once this is cleared, it would go on to the next statement, of which there is none, but you'll see some today. So a function is one way to create a block of code that maybe is run several times in the course of the web page, or maybe it's reusable code that you want to use in a lot of different programs. So you're going to write it as a block of code that you can copy and paste in different JavaScript scripts. We'll see more of that today also. This starts to get into the stuff we saw with the email program, which I said was complicated. Here they've created a function expression called $. It accepts 1 parameter, and this is what it returns. So when it's called with its name, $, it passes this parameter, which is the ID in HTML of where it's going to print to, okay, and grabs its value and stores that in email address. So this statement here needs to work with this one to get the email address 1 variable updated with the right information. Okay. 2 parameters instead of 1. This is what I call a named function. They call it function declaration. This is kind of old school. This is the way they traditionally have been brought up. This is where Python and C and a lot of programs work with it. You have the keyword function, you have its name, then you have the parameters, and then inside the curly braces, you have the statements that are going to be run. So this is show year as a named function versus the function expression, which was a couple slides back. For me, this is more intuitive, but I think it's because I probably grew up with it. The way it's called is the same way, and what it does, it comes up here, looks for a show year function, runs the statement, and finishes this, and then continues on to the next statement after that. Let's see. More examples using named and function expressions. There's also something called local variables versus global variables. A local variable is a variable that's defined within a function, either function expression or named function, and it's only valid within that function. To try to use it outside the function, okay, again, alert is not in there, alert is outside, will give you an error because the only thing that knows about this tax is this calculate tax, so it has to be used from within here. Okay. Global variables are defined outside of a function, somewhere else in the JavaScript, and they are visible to all of the statements inside the script. But local variables can only be seen by the function that they were defined in, unless you pass it out to them. You can also, like in this case, this function does return tax, okay, but that would have to be something like, it said something like, text message equals calculate tax, double parentheses, and that would send that tax information to a variable. Then I could print an alert, but not the way it is now. The way it is now, it's a local variable. This is a common logic error that programmers make, is what they're demonstrating here. They forget that it's local. Global is a different story. See here, this tax is defined outside this function, and therefore it's available for this function, but it's also available for this statement here. So that would make tax available everywhere. You've got to be careful. The common thinking is make everything global because I don't have a problem. But there is a problem. The problem with that is you're defining variables you may not use. If it's just a local variable to this, that's all it needs to be used with, is with this function. And the other thing is too, is it doesn't make your code very reusable. If you try to pick something up and put it in another program, if it's global, you have to make sure the global variable exists, otherwise it's going to fail. So typically what they'd like you to do is if something is just going to be used within a function, make it local, define it that way. More errors. Use strict is something which is new to a couple versions of JavaScript. And basically what it says is that all variables have to be declared before they're used. So in which case, usually put in there to help you isolate errors that are probably more typos. You forgot to put the var in to identify as a variable. You used it before you did that. It doesn't like that. The error pops up. You can fix it. Okay. The last thing is events here. We have an example with a click event. And what events do is it makes that browser interface interactive. We can click, we can blur, we can change, we can select. We can do different things to text boxes, to images, etc. And we can set up JavaScript to respond to those. Remember, JavaScript is supposed to make the page dynamic. It's supposed to be able to change on the fly, locally inside the browser. These events are what make that happen. Here's a sample of some of the things we can do in JavaScript to invoke code to make the page change, or more importantly, the pages of the DOM, they're the same, or make the DOM change. I'm going to just kind of blow through these because I have a better example to show you in just a second, so I will do that. I'll cover chapter 5, another video, because I think I'm kind of running long on time here, and I can do chapter 5 by itself.